Dinosaurs are among the most remarkable creatures in Earth's history, dominating terrestrial ecosystems for more than 165 million years. Their story begins during the late Triassic period, over 230 million years ago, a time when the Earth looked dramatically different from today. The supercontinent Pangaea stretched across the globe, forming vast deserts, mountain ranges, and seasonal rivers. The climate was harsh, with extreme temperature fluctuations and unpredictable weather, yet it was within this environment that the earliest dinosaurs emerged. Small, agile, and bipedal, taking their first evolutionary steps in a world dominated by larger reptiles and early art. Among the earliest dinosaurs were Eoraptor and Herrerasaurus, both from present-day Argentina. Eoraptor, measuring just over a meter in length, was a light and fast carnivore, hunting insects, small reptiles, and other Its anatomy reveals upright posture, long hind limbs, and a flexible tail, traits that would become defining features of dinosaurs. Herrerasaurus, slightly larger and more predatory, shows early adaptations for hunting, including sharp teeth, strong jaws, and grasping forelimbs. These species demonstrate that even the earliest dinosaurs were specialized, resourceful, and highly adaptable. During the late Triassic, dinosaurs remained relatively rare. They shared their ecosystems with large, dominant reptiles such as phytosaurs. These competitors were often larger and more powerful, yet dinosaurs survived by occupying niches that others could not exploit. Small size, agility, speed, and possibly early forms of social behavior allowed dinosaurs to persist. The end Triassic mass extinction, likely caused by massive volcanic activity and climate disruption, wiped out many competing groups, leaving ecological opportunities that dinosaurs rapidly exploited, setting the stage for their dominance in the Jurassic. The Jurassic period, beginning around 201 million years ago, brought dramatic changes. Pangaea began to fragment into smaller continents, creating diverse climates, isolated habitats, and new ecosystems. Rainforests expanded, rivers meandered across plains, and coastal environments flourished. In this dynamic world, dinosaurs radiated into countless forms. Giant sauropods, including Brachiosaurus, Diplodocus, and Apatosaurus, evolved into colossal herbivores with long necks, massive bodies, and pillar-like limbs. These giants transformed landscapes, feeding on treetops and shrubs, and likely influencing plant evolution through their grazing. Theropod predators diversified alongside sauropods. Species such as Allosaurus became apex hunters, capable of taking down massive herbivores, while smaller theropods experimented with speed, agility, and novel hunting strategies. Fossil trackways suggest some theropods hunted in coordinated groups, indicating social behavior and complex communication. The first evidence of feathers appears in small Jurassic theropods, initially as simple filament-like structures. These early feathers likely served as insulation, camouflage, or display, setting the stage for later flight and the evolution of birds. The Cretaceous period, beginning around 145 million years ago, marked the pinnacle of dinosaur evolution. By this time, the continents had drifted toward positions closer to today, creating diverse ecosystems, mountain ranges, and isolated habitats. Flowering plants appeared and rapidly spread, transforming landscapes and providing new food sources for herbivorous dinosaurs. Zichion, including ceratopsians, hadrosaurs, and ceratopsians developed elaborate frills and horns, potentially for display, species recognition, and defense. Hadrosaurs evolved complex dental batteries, enabling efficient chewing of tough vegetation. Ankylosaurs developed heavy armor and tail clubs, providing formidable protection against predators. Theropods continued to evolve in parallel. Tyrannosaurids such as Tyrannosaurus rex became apex predators in North America, capable of overpowering large herbivores. Smaller theropods, like dromaeosaurids, including Velociraptor, remained agile, using intelligence, speed, and possibly cooperative hunting techniques to capture prey. Feathered theropods diversified widely, some capable of gliding or powered flight. Fossils reveal nesting behavior, parental care, and elaborate display features, indicating highly social and behaviorally complex species. Feathers were used not only for thermal regulation but also for visual display, communication, and camouflage. The evolution of birds represents a crucial milestone in this timeline. Small, feathered theropods developed wings, asymmetrical feathers, and adaptations for flight. Archaeopteryx, from the late Jurassic to early Cretaceous, displays a combination of dinosaurian traits, including teeth, claws, and a long bony tail, along with avian adaptations for flight. Over millions of years, birds diversified into countless forms, surviving the mass extinction that wiped out avian dinosaurs at the end of the Cretaceous. Throughout the Mesozoic, dinosaurs exhibited astonishing diversity. Body sizes ranged from chicken-sized insectivores to the colossal Argentinosaurus, over 30 meters long. Ecological roles varied widely, with herbivores shaping plant communities and predators maintaining balance within ecosystems. Adaptations included feathers, armor, horns, crests, and advanced sensory organs. Social behavior evolved, including communication, parenting, herd coordination, and possibly complex learning. Evolution experimented continuously, responding to changing climates, vegetation, competition, and predation pressures. Fossil evidence provides a multifaceted picture of dinosaur evolution. Skeletal remains reveal anatomical innovation. Trackways and footprints illuminate movement, group behavior, and predator-prey interactions. Nesting sites and eggs reveal reproductive strategies, incubation, and parental care. Feather impressions and melanosome analysis show coloration, display, and thermoregulation. Combined, these lines of evidence reveal dinosaurs as dynamic, adaptable, and behaviorally complex animals. Environmental factors shaped evolutionary plate tectonics, altered habitats, created barriers and corridors, and influenced climate. Volcanic activity and sea level fluctuations affected available ecosystems. Dinosaur lineages adapted to deserts, forests, plains, and coastal areas. Feeding strategies evolved alongside plants, including cycads, ferns, conifers, and later flowering plants. Predator-prey dynamics drove anatomical and behavioral innovation, with faster predators leading to faster prey and armor and display features evolving in response to hunting pressures. Throughout their evolutionary history, dinosaurs displayed remarkable adaptability. Small, agile species exploited niches in forests and plains. Gigantic sauropods fed on treetops, unreachable by other herbivores. Armored dinosaurs developed defensive innovations. Feathers provided insulation, display, and flight capabilities. Social behaviors, parental care, and communication evolved to increase survival and reproductive success. These adaptations allowed dinosaurs to dominate Earth's ecosystems for more than 165 million years. The end of the Cretaceous, approximately 66 million years ago, brought catastrophic changes. A massive asteroid impact, combined with volcanic activity and climate disruption, led to the extinction of nearly all non-avian dinosaurs. Despite this mass extinction, the evolutionary legacy of dinosaurs continues through birds. Modern birds inherit feathers, skeletal adaptations, reproductive behaviors, and many ecological roles from their dinosaur ancestors. Studying the dinosaur evolution timeline provides insight not only into their anatomy and behavior, but also into the broader processes of evolution, adaptation, and ecological dynamics. Dinosaurs exemplify the interplay of anatomy, environment, behavior, and innovation over vast time. They demonstrate how species can diversify, specialize, and survive through constant environmental change, leaving an enduring legacy in the living descendants that soar through the skies today. From the small, agile Eoraptor of the late Triassic to the colossal sauropods and sophisticated theropods of the Jurassic and Cretaceous. Dinosaurs continuously adapted, innovated, and diversified. Feathers evolved into complex structures supporting thermoregulation, display, and flight. Armor, horns, and crests evolved for defense, display, and species recognition. Social behaviors such as communication, parenting, and herd coordination enhanced survival. Birds carry forward the evolutionary innovations of their dinosaur ancestors, connecting deep time to the present day. The timeline of dinosaur evolution spans millions of years of experimentation, adaptation, and ecological mastery. Dinosaurs navigated changing climates, continental shifts, new predators, and novel plant life. They grew to incredible sizes, developed remarkable anatomical innovations, and exhibited complex behaviors that ensured survival. Their evolutionary journey exemplifies life's resilience, creativity, and adaptability on a dynamic, ever-changing planet. Understanding this timeline allows us to appreciate the diversity, ingenuity, and lasting impact of dinosaurs on the natural world, from the earliest Triassic pioneers to the birds that inhabit every continent today.